What's up YouTube? Today I want to talk about what I think is the most underrated EuroRack module on the market. So this is a bit of a strange one because it isn't a particular developer or manufacturer that creates it. It's an open source project called Ornament and Crime, and on top of that I actually don't think that the kind of factory OS is where it's really at with the Ornament and Crime. Today I want to show you guys the Hemisphere OS in Ornament and Crime. So like I said, Ornament and Crime is a open source project. There are various kind of like DIY things that you can order, like panels and sets that you can build yourself. There are various manufacturers that do kind of build the sets, and I think you can get them from Pusherman and various other places. Big T Music. I'm sure the Behringer version is coming soon. Just kidding. Anyway, today I want to go through every single mode in the Hemispheres mode, and I want to show you guys, why I think it's so much better than the original firmware, and a couple of other really cool things about the module. There are so many different modes, but that being said, I think once you guys start to get the grip of it, you'll start to understand, how it's kind of like designed, and then the modes just kind of become self-explanatory. Some of them are a little bit cryptic, but the rest of the stuff is pretty self-explanatory. It's like the best Swiss Army knife module on the market at the moment, I think. It's almost like it's all those other modules that you might need in a single one. Anyway, without blabbering on too much, let's dive into the module and have a closer look. So there's a really handy website called synthmodes.com, which has like a reference of most of these, most of the modes in Ornament and Crime Hemisphere mode. If you just search Google for Ornament and Crime Hemispheres, then that'll be the one that'll come up. So yeah, I still use it when I'm unsure of what the modes do. But that being said, is like if it's in a particular mode and you just double click, it'll show you what the kind of ins and outs of that particular mode are. So that's really, really handy thing about the way that they've kind of designed this particular mode. So another really, really cool thing is that it's kind of split into two. So you can use each of these like mini modules independently of each other, and some of them even stack up. So for example, like the analog shift register, if you load it up on both channels, then instead of being a kind of 2-channel analog shift register, it works as a single 4-channel analog shift register. So yeah, these are just some of the cool things. I'm going to talk about a little bit of navigation, about how the thing works, and then we're going to talk a little bit about each of the modes, and I'm going to show you a couple of examples for each one. So how it works is, to change the modes, you just click the corresponding button. So the top one would be for the left-hand side, bottom one would be for the right-hand side. Again, like I said, to double-click will show you what each of the ins and outs are doing. If you long press on the bottom button, it opens up the clock setup. So this allows you to actually enable an internal clock. So let's say, for example, set this to internal. You can actually choose the BPM over here, and then it's got a multiplier as well. So we can jump out of the internal clock mode. And then if you long press the left encoder, when you release it, you'll see it actually starts the internal clock. So you can actually see this random of this mode is now randomizing at 120 BPM. To long press on the left encoder is to enable or to play the clock, and to pause it again. If you long click on the right encoder, it opens up the advanced settings. I'm going to go through all of the stuff in the hemisphere mode in this video, and we're also going to look at the waveform editor. All of these other advanced things I'm going to stay away from for today, just because they're a little bit more advanced. Some of them do actually feature kind of more basic versions within the actual modes themselves. So once you're in this like menu, if you long press on the right encoder again, what will happen is it will save the mode. I don't want to save it now because there's particular settings that I usually use on a daily basis, so I don't want to recall those. But you'll see it saves when it actually a thing pops up on the screen, a little indication that you've actually saved, and then you know, okay, cool, I've saved. So again, we can change the modes by just clicking on each one, and if you click in with the encoder, it changes different parameters within the mode. Left encoder obviously deals with the left module, and the right encoder obviously deals with the right module. So as you can see here, I've got like an envelope loaded, and we can actually go in and actually fine tune the attack, the release, decay, and all that stuff by just clicking the single envelope. So this is a bit different. It's not quite menu divey because you set the mode, and then, it's actually quite a playable thing. Whereas, generally speaking, I kind of tend to stay away from modules that are too menu divey. So that's why I don't like the original OS of Ornament and Crime, because there's a lot of settings that you've got to kind of go in there and fine tune, and all the kind of tuning stuff. It's very advanced. So these hemisphere modes are much simpler. A lot of them are either taken from like quantizers and stuff, which are from the original OS, but then there's a lot more stuff in here as well. So let's start off and just go through things alphabetically, or as they appear in the menu. First and foremost, we have the ADSR EG and AD EG. So these are similar but also a little bit different. ADSRs generally react best to gate signals, whereas ADs generally react best to trigger signals. ADSR, we'll just go through the ADSR first. So this is a simple envelope generator. CV input 1 controls the attack. CV input 2 controls the release. There are actually two envelopes inside this mode, each triggered by trigger input 1 and trigger input 2. They both are the same envelope shape though, so you can set one shape and trigger them independently, so you can have the same shape on two envelopes basically. And then the outputs 1 and 2, or A and B, those represent the two different envelopes. So envelope being triggered on trigger 1 and envelope being triggered on trigger 2. So the AD is similar but different, like I said. So instead of having two built in, if you trigger the first one, it reacts like a regular AD generator. If you trigger the second input, it just works in reverse. So if you have a saw ramp down shape and you trigger it with the second input, it saw ramps up. So the CV inputs are attack and decay, and then the outputs of the AD represent the actual shape, and then the second output is the end of cycle trigger. So as soon as that envelope reaches the end of the cycle, it spits out another trigger. So you can use this to re-trigger itself and do all sorts of things. You can create like a looping envelope using the end of cycle back into the trigger, and all sorts of interesting things like that. I'm going to patch up a quick example here so we can just hear exactly what's going on here, and I'll patch in some CVs and all sorts. Okay, so in this patch I've got the ADSR and the AD envelopes. They're being modulated by a Wogglebug and a function generator off screen, and those are controlling the phase locked loop. The ADSR is controlling this kind of like offset amount, as well as the couple of parameters on the input, which is coming from the mind phase actually. The second one is actually doing a filter of the saw wave output from the mind phaser. And then I've also got a kick sample being played here to make this kind of like techno loop. Okay, so the next modes I want to have a look at are Annular Fusion, which is a Euclidean circles, basically like this module over here, but it's a dual channel. You can actually set this up so that it's 4-channel, on both the left and right modes. So if you get, for example, there's a UOC, a micro, which is like this size. If you have that module, it's actually more efficient in space and in function than the Euclidean circles itself. Although that being said, is this kind of like playability of this module is very nice. I kind of really like this. So I'm still, unsure whether I'm going to swap out, all that kind of stuff. But anyway, I want to show you how cool these modes are together. Analog shift register and annular fusion. Analog shift register is kind of like a sample and hold, but what it does is it samples, you can see here you've got an index number. So it samples a voltage value onto each of the indexes, and then you can recall those values using a CV. So that means it kind of works like a sample and hold in terms of the fact that it's recording a CV value and then spitting out a CV value, but it's not holding that value. It is holding it kind of in memory, but you can kind of choose which values to spit out. So this is really nice for creating sequences, but then modulating the kind of phase of that sequence and kind of which note is playing and that kind of thing. And the extra bonus is that this has a little quantizer built in. So it's just instant melodies for days. You can literally feed it anything from like LFOs to random shapes to function generator stuff, and it generally spits out cool melodies. If you just modulate the index and you loop that modulation, you get you kind of freeze that melody. This is nice with something like an analog sequencer or alongside something like just a regular LFO, because that will cycle through the same shape over and over again. So back to the Annular Fusion. This is a Euclidean step sequencer. So how it works is the button, the encoder button basically cycles through the amount of steps, the amount of hits, and then the amount of steps and the amount of hits for the outer ring. So if you press it 3 times, you swap to the inner or outer ring, and there's 2 rings. Each one can hold that kind of step data. So what I want to do is I quickly want to patch this up to create like a drum thing using the phase locked loop, the error instruments, and then we're going to create a melody using the analog shift register real quick. So sending CV into the corresponding input basically offsets the rotation of that circle. So I've got a random CV coming in here, and notice how when I turn the amount up, it starts to rotate that circle. So this is really nice for just like, finding a groove and then shifting it slightly off to kind of create these like intricacies. Obviously if we're creating something like a simple techno pattern, we don't want everything to just be on the 4. You know what I mean? So being able to kind of shift it or rotate it is so cool. So this is the result then played alongside a kick drum, which is on the 4. So the analog shift register, like I said, is a bit strange to wrap your head around at first, but it kind of, like I said, it works like a sample and hold generator, except you can choose what values it's sending out via this kind of index parameter. So the first CV input is what's recording the value. So as you can see here, I've got an LFO running in. And the second input basically offsets which index is reading to send out. The first trigger input basically advances the clock. In this example, I've got it running in forward mode, so the clock is being received from the first hemisphere anyway. And then a gate received at the 4th input starts the recording process, which I've already done. You can actually just plug a cable in there and stick it in your tongue if you want. Anyway, so yeah, what I'm going to do is let's send this CV output. So the 2 outputs correspond. The first one is the actual value that's currently being read, and the second output is the previous value that's being read. So this is pretty cool if you're wanting to create kind of juggling melodies where the melodies are playing the same kind of sequence but slightly out of phase from each other, maybe being gated independently. So you have like a single piece of music that's being played by 2 different rhythms or something like that, which is pretty interesting. Analog shift register is also one of the modes that can be run in what's called linked operations. So that means you can actually load it up on both hemispheres, and it works as a 4-channel analog shift register. That's a little bit above my expertise though, so I'm going to stick with the 2-channel for now. We've got a nice little rhythm going on the Annular Fusion, so we can actually do like a rhythm and a melody using this these simple modes over here. Okay, the next mode I want to look at is AttenOff, which is a very simple attenuator offset. So what you can use this for is just to send straight voltage to something. If you want to like tune an oscillator or change a CV value to a very specific thing and you want it to kind of stay there statically, you can use the attenuator for this. There's also a mode called voltage, which you can use for that, which has other various features. But I guess attenuator offsets work best in an example where they're receiving modulation. So in this example, I want to patch in a random into... I want to patch a random modulation into the input, and we're going to send that into the filter of that melody I was creating. And then notice how you can kind of change the percentage value of the amount of modulation going through and the just raw offset of voltage. Check this out. So this is probably the strangest mode of all, binary counter. What it's doing is it's taking a gate signal into each of the trigger and CV inputs, and as you can see, the gate up corresponds to a binary plus or a 1, and the no gate or gate down corresponds to a binary 0. And then the two outputs either do like a sum, so it'll be like the total of all of these, like the binary sum, or it will do a count. So A would be the sum and B would be the count. So what I'm going to do is that kind of drone thing that you heard, I'm going to send these outputs to different modulations within that kind of like drone sound, so we can kind of see how experimental we can get with this. Like I said, this is a weird mode. I can't really see where I would use this musically, but again, just having it at your disposal, being able to do weird things like that within music is cool. So anyway. I present to you BootsNCat mode. So this is a snare and kick drum generator. It is a bit lo-fi, so I don't use it that much for like psytrance kicks and snares, but it's just such a cool utility having, like distorting this kind of thing just to create extra percussive patterns. You can actually go into the waveform editor and change the waveforms of these things. It's pretty fucking mind-blowing what you can do. But that's on the advanced side of things. This is more of just a run-through video. If you want just like more advanced waveform editing stuff, then let me know. Anyway, the triggers obviously correspond to kick drum and snare. And here you can see I've got the Annular fusion mode loaded up. So what I want to do is I'm going to trigger the kick and the snare using the Annular fusion Euclidean circles mode on the actual unit itself. So just keep this in mind. You can create these sounds using only this one module. You can sequence it and create the drums. It's freaking mind-blowing. The CV inputs correspond to like a VCA level of the individual drums. That being said, I'm just going to leave that. I'm not going to CV control these for now. I'm just going to trigger them. And then the encoders, you can obviously change the tone and the decay of each of the instruments. The blend, you can actually set them to both send out to a single output, which is pretty cool. So how that works is if the blend, I think, is all the way, then you'll hear both kick and snare on one output. So I'm going to run this through a distortion on the Mutant Hot Glue, just to kind of liven it up a little bit and show you guys kind of the versatility that you can do with this. The next mode is Brancher. This is basically like branches, the mutable instruments mode, or the green T mode in Marbles. I think you guys are starting to see where I'm going with the efficiency of this thing. It's replacing so many other modules in my rack because I can quickly just, for example, load up a brancher and it's doing what Marbles was doing in my other thing. There's also a burst mode, which is another mode from Marbles. It's so much cool stuff in here. So what branches is a probability sequencer. It receives a trigger, you put in a percentage, and it spits out a gate at either A or B. So I'm going to leave this triggered as is, and what's going to happen is it's going to probabilistically trigger the kicks and the snare. We can change the probability either with the encoder here, or we can CV control it using the CV input. Okay, the next mode is Burst. This is a little bit hard to wrap your head around at first, but how it's working here is this is receiving the clock input, as usual. This is receiving a gate trigger for when I want the burst to start, and then this is, the CV is the amount of hits in the burst, and this is being randomly modulated with the Wogglebug. This is then sending that burst amount out to the snare, and then I've just got a regimented kind of trigger triggering the kick drum here. So it's doing these kind of snare rolls. Okay, so the next mode is calculate. So this is like a little mini make noise maths as well as a little mini make noise Wogglebug in one. Obviously maths has a couple of other things and Wogglebug have a couple of other things, but this has so many other modes that it just makes it so much more efficient. I mean, here for example, this calculate mode has various different kind of arithmetic functions that you can apply. So you basically send it CV voltage, you can set it to min and it punches out of the CV. It sends the output the minimum voltage. Maximum sends obviously the maximum voltage. Sum is it's like mixes the two voltages together. Difference is basically A CV minus B CV. Mean is the average of the two. Sample and hold basically takes the value and holds it until the next trigger is received. And random just spits out random values, but this can be clocked. In forward clock mode, just set this on, you'll see that we can have 4 independent random generators in the same space that the Wogglebug is creating 1. So obviously the Wogglebug has like the curve control and some other things like that and the audio sources, but having 4 sample and hold randoms that you don't need to send a CV, that's just so easily accessible. I mean, I don't think I'd ever need 4 of them, but like having 2 and then another module, it's guys, you don't understand. This is the most underrated module. I've never seen anything quite like it. Anyway, I'm obsessed with it in case you guys didn't notice. So this is the mind phaser through ripples making this sound. So Carpeggio is kind of like a make noise René, but with a quantizer built in. I don't know if the René has a quantizer built in, but here you can actually choose the exact kind of chords and scales that you want to work in. And how it works is you send it CV to control the X and the Y, and then you trigger it. Here I've got, on the first hemisphere, I've got a calculate, which I'm going to randomize, which is going to choose the X and Y positions on this Cartesian plane. And then the clock is being sent through from the forward trigger, and it's going to create a melody for us. So here we can actually choose a particular scale to quantize to. So it works with chords, in fact. So we can do like minor triads, minor inverted 1, inverted 2. I think minor is going to work best here. And then you can actually transpose it up and down. You can also trigger this with like something like LFOs, which is pretty cool. So you can kind of sequence that particular melody kind of like more linearly. So I'm just going to send in function generator stuff here. So the next two modes are clock divider and clock skipper. I'm not going to go through two in-depth examples of what these are. I'm not going to show you like audio examples and stuff because they're pretty straightforward. I guess the sort of easiest thing to, or I guess the one thing I should probably explain is that it's got CV input. So you can actually control the divisions, and it's two channels. So if you clock it, you can get two different divisions out that are CV controllables. That's nice for creating variable kind of grooves and stuff. If you're wanting to kind of ratchet hi-hats, you can send it a very fast clock and then kind of like CV control various different time divisions of that very fast clock and stuff. So yeah, that's a pretty handy thing. Clock skipper is a bit weird. I don't think I would ever use this because what it's doing is it's essentially removing some of the clock signals probabilistically. So I guess this could be cool for creating weird randomness and stuff like that. But again, I probably wouldn't use it. CV control changes the probability of each of the channels. Okay, so the next mode I want to talk about is compare. So this is a basic comparator. What that's doing is it's basically taking a CV input and it's comparing it to another CV input. And it gates high if it's lower, and it gates the other gate if it's higher. So what I'm going to do is I'm going to send a random CV into the input. As you can see, it's triggering over there. Then what I'm going to do is I'm going to send an offset voltage from the second module, which is an attenuator offset, into the comparator. And I'm going to get it to gate to trigger the error instruments every time the random is above a certain voltage. The next mode is CV recorder. So this is really cool for randomizing a CV and then recording it in and then looping it over and over again. So you can do various things with this, creating sequences or even just random modulations that you want a kind of more regimented kind of, how can I say, that you want a looped pattern on that sequence. It's also got a smooth parameter, which is pretty interesting. So how this works is a clock to both the inputs will keep resetting it. So what I want to do is I actually want to reset it at the beginning of every bar. So doing that, you're essentially choosing the amount of steps in the sequence. So you can see here I'm recording a quick 16-step sequence. So the interesting thing with this is it's actually a 2-channel CV recorder. So out of the Wogglebug, I'm going to send it the smooth and the square random. And we're going to record that in. So because we've recorded 2 channels, both the smooth and the squared, we can modulate something else with that smooth parameter. So let's modulate like the pulse width of a square wave running into that filter. The reason I think this is really powerful is this now frees up our randoms to modulate something else in the patch if we wanted to. Not sure like what else I can modulate, but let's just see what we can do here. The next mode is DrCrusher. This is a sample rate and bit redux effect. So I'm going to show you pre and post. I've created a little switch. This is the pre, and then I'm going to do the post. Pretty awesome sounding little DrCrusher, and the fact that you can like load 2 of them up, oh my gosh, guys, I cannot keep stressing that this is one of the best modules that you can get yourself, especially if you're getting into Eurorack and you're like kind of trying to get a efficient small system going. This is going to kind of kill 52 birds or 51 birds with one stone. Anyway, I believe how it works is out A sends the bit reduce signal and out B is the dry signal, so you can quickly create a dry wet using a switch. Okay, so I want to show you the next 2 modes together. Dual quantizer is exactly what it says it is. It's a dual quantizer. It can quantize 2 CV inputs and send 2 CV outputs. What is quantizing? It's taking a continuous CV value and chopping it into squares, which are in tune to particular scales and such, which you can set on the parameters over here, as you can see. So Enigma Junior, I'm not going to explain what Enigma is. It's this whole other completely advanced thing all on its own, which you can actually get to by long pressing the right encoder going over here. Like I said, I'm not going to get into that. It's very advanced. Enigma Junior, however, is a little bit more easier to wrap your head around. What it is it's a library of Turing machines. And Turing machines are essentially random generators. So the reason I wanted to show you guys these 2 together is this is essentially never-ending random sequences which you can kind of lock into particular patterns and all sorts of cool things. You can modulate which libraries you're grabbing from, and then you can quantize them using this to create all sorts of cool melodies and stuff like that. You can choose which register you're calling from, so that would be which Turing machine you're calling the sequence from. Then you can choose the probability at which it's going to generate a gate. You can assign the outputs, so you can actually have 2 different notes. You can have like 2 different kind of like notes sequences running out of one Turing machine, and then you can select them to have like these kind of like patterns that work together, all sorts of crazy things. You can gate, send a trigger, all sorts of things. So you can assign those outputs to whatever you want. You can actually modulate between these different registers as well. So you can get some really, really evolving melodies that kind of evolve over time and all kind of sound like they're from the same thing, but forever evolving. So the next mode I want to discuss is envelope follower. So obviously what this does is it takes a signal input and it derives an envelope from the audio signal. So this is particularly cool for sending it something like a kick and a bass and being able to create like an enveloped kind of thing using that. You can use it for sidechain stuff. It's actually so useful. In this example, I've got a kick and bass running here. I've got a switch to send it through a filter, but I think what could be interesting is to kind of derive an envelope from the kick and bass to apply to that filter to kind of give it a little bit more of a transient motion, so it's just not such a flat filter. Let me show you a quick example. CV inputs 1 and 2 are two independent channels. You can set them to follow or duck mode. So follow derives a kind of decay motion from an audio signal, where duck kind of derives a attack motion, kind of like for sidechain types of things. You can actually set each one independently, so you can have a follow and a duck, or two ducks, two follows, etc. And then you've also got like a gain, an audio gain for each of the channels, which just helps to kind of like fine tune that a little bit more. So yeah, what I'm going to do here is I'm going to send it the audio from the kick and bass, and then send the modulation of that that's derived from that audio back into the filter, and we're going to play around a little bit with this. So in this example, I've sent the kicks output into both of these inputs, the actual volume, the actual audio output into both of these CV inputs. And then this first channel is controlling like a sidechain of the bass. And then the second channel is controlling the ducking motion. So it's like the opposite of a sidechain on the mind phaser, which has a bit of filter going on just to create like a kind of stabby sound at the beginning. So the next thing is the gate delay. So this is a really simple, it just takes gates and it delays them. This is great for offsetting triggers, for phase correcting kick and bass, if you want to get that in depth with it in the modular rack. I don't usually. You can also use it to create swing. So the CV inputs actually correlate to time modulation per channel. So you can send in a CV input here, which can actually change the offset in milliseconds. In this example, it's probably not going to work that well, because what I want to do here is just slightly offset the kick and bass. Here, what I've got is kick is running into channel A, and the bass is running into channel B. And we're just going to offset the time of the bass ever so slightly. So the next mode is gated VCA. This is a VCA. It expects a CV input on the second one. You can just gate it for like a quick pluck sound, but I find that having envelope control going into the second CV input helps to create more of a kind of it's a slightly better sound. You'll hear what I mean. So output, the first output outputs just the first transient, and the second output outputs the whole envelope cycle. Check this out. And the next mode I want to have a look at is LoFi tape. So this is just a sample recorder. You can record a quick kind of lo-fi sound and play it back out again. So I'm actually just going to use this exact sound that we've created here, patch it into the input, just press the encoder in, and you can see it's recorded us a little sample over there. That is super cool. And I was playing it back over and over again. So the encoder determines the length of the loop. So you can create these like glitchy retrigger patterns by just changing the encoder. This is really cool, eh? In combination with something like the mimeophone, you can create such cool granular-like stuff. And on a side note, the second CV input here controls the mix of the incoming audio and what's actually playing out of the tape buffer. That is a particularly cool thing, hey? Just for random recording and glitching and stuff. Such a cool little thing. I love it. So the next mode I want to discuss is logic mode. So this is pretty simple, but also at the same time, at first, might be a little bit difficult to wrap your head around. So this contains a 2-channel logic processor, and logic happens in various different styles. Here you can select the different styles you get. So if you can see here, we've got a Euclidean circle doing a pattern of 4 and a Euclidean circle doing a pattern of 3. The AND logic gate is only triggered on the first step, because that's the only time when these two triggers actually correspond. You can see that. If we set the second Euclidean circle to steps of 4, it triggers on every 4 because these correspond. So what happens is the logic is set to AND. So this means that when a gate is positive at both inputs, it triggers the output. You can set that to something else, and you'll see whenever the gate corresponds, it triggers. So AND is when it receives two positive inputs. OR is one or the other. So this is true when either of the inputs or both inputs is true. So this is basically like a gate combiner. Here what we can do is, let me actually just send this to a quick output so you can kind of hear what's actually happening here. So as you can see, logic is a great way of combining two very simple rhythms to create a much more musical rhythm, specifically using that OR function. Then you get XOR, XOR, or exclusive OR. What this is only triggers when one or the other input is active. So this won't trigger when two inputs coexist, but it will only trigger when one or the other happens. Check this out. NAND is true when either input is false. This is a bit weird, I don't use it that much, it's not so good for kind of rhythmical stuff. Then you get NOR, which is true when both inputs are false. And then XNOR is true when both inputs are the same. So whether they're false or positive, as long as they're the same. The next is LowerRenz. This is a random modulation. I'm sure you guys know the Lorenz Attractor in Vital. Serum also has a very similar setting with a chaos oscillator. This is, two random generators, and I believe they're kind of based on gravity and planetary stuff. Anyway, I'm going to send the one modulation output into a pitch of an oscillator and the other one into the frequency of a filter. And then I'm going to gate it and we're going to try to create some squelches that way. So with the LowerRenz, this resets the modulation, so I think that like triggers it so that you can get kind of more, I guess it's circular, so it wouldn't ever be clocked, you know what I mean? But I guess that re-triggers the automation. The second input freezes, so I guess you could do like a sample and hold thing with this, where you could freeze this, you know, every clock or something, and then reset it. And then the CV inputs to each of these first and second CV inputs. First one corresponds to the frequency, and the second one corresponds to RHO, which I believe is like the magnitude of gravity that's pulling these things. So the next modes are MIDI in and MIDI out. So I'm not going to go through in depth on how this kind of works, but just for a quick explanation, yes, the Ornament and Crime actually does have a USB port at the back. You can plug it into your computer, and you've got a MIDI input and a MIDI output. You don't have to use them together. You can actually set one to just MIDI in, one to just MIDI out, or however you want to configure it. That's the kind of beauty of the Hemispheres mode. So it's configurable, so you can choose whether you want notes, gates, triggers, all that kind of thing. The cool thing about it is it's kind of configurable on the fly. A lot of the other stuff you have to kind of configure on the computer first and that kind of thing. So this is really cool for, you know, if you quickly want to do something with like a portable rack, you can kind of plug it into any computer and that kind of thing. That being said, it's a bit difficult to access the USB at the back of the thing, so you're probably going to want to plug it in and have a cable kind of running out the side of your rack, or I don't know how you're going to set that up, but it's up to you. It has it if you need it, which is really cool. The next mode is Metronome. So this is a quick and easy way to access the internal clock. Remember how I was showing you guys, you know, when you long press on the second button, you get this kind of internal clock setup. You can use this kind of independently, and it's a nice way of being able to quickly control it by, you know, pulling it up, changing the settings and that kind of thing. So the encoder basically changes the tempo, and then the outputs correspond to the first one being multiples, which you can set in the internal clock menu, and then the second one being every clock pulse. The next mode is mixer balance. So this is a very simple mixer that can mix between two signals, A and B. The encoder controls the balance of those two signals. So here I've got a square wave coming from the mind phaser. On the other side I've got the kind of post wave shaper and phase modulation bus input coming in, and then it's going out into a filter. So you can mix between these two signals, you can isolate them one or the other. You can actually load up two, so you've got a little 4-channel mixer with 2 outputs, which is pretty cool. You can run the one into the other and all sorts of things, so you've got a full 3-channel mixer. Anyway, so this is just a quick example of how useful it is on an oscillator when you want to mix between, or when you want to mix two you know, oscillator shapes together. So the next mode is palimpsest accent sequencer, or just palimpsest. What this is it takes 2 gate or trigger inputs, and it derives an accent sequence from the two different gates. So you can also modulate the compose and decompose settings. So what that does is it basically adds more or reduces the amount of triggers. So I've got random modulations going in there, and the first input is a clock, and the second input is like a trigger coming from the Euclidean circles. So we can kind of create these variable accented sequences by just triggering this with different numbers. So this is really cool for kind of like acid patches. The sound source here is the mind phaser. It's being sequenced by Ornament and Crime here. I'm going to get to the sequencer mode just now. And then, yeah, with some filter from the ripples. So the outputs in this mode, the first one outputs the accent, and the second one outputs whenever the accent is derived below a certain point, if I'm not mistaken. So here what we can do is we can use this to clock the random. So each time it does an accent, it changes the decompose setting. So then we'll get these kind of variable accents that change over time, and then we can change the number of steps in the Euclidean sequence to also get some variables going on there. So the next mode is Wogglebug. What happens here is it's kind of like a Turing machine in the fact that it's also a shift register. It's a lot more chaotic though, it's a lot more random. So here you're taking an input from a modulation source. It could be random, it could be an LFO, whatever you want, and then it's deriving modulations from that. One of the modulations it derives is like the first half gets sent out the one output and the second half gets sent out the other output. And here I've got it going to the pitch and the filter cutoff. The first trigger input advances the clock, and the second trigger input basically freezes the buffer at that point. So this is, if you like that particular pitch at that moment, you can quickly like trigger it and it freezes that, and then you can kind of build these kind of modulations at these, depending on how you kind of record that buffer in, if that makes sense. So the next mode I want to discuss is scale duet mode. This is a single channel quantizer, but the interesting thing about this is that you can trigger to switch between two scales. So this is nice for evolving melodies. You don't necessarily have to switch between exact scales. The nice thing about this is it kind of acts like Vital's quantizer in that you can pick the notes that are in the sequence. So what I'm going to do here is I've got an unquantized analog voltage coming from a sequencer into the CV input. The clock is being triggered into number 1, and then number 2 is just an always on that I can switch on and off, and this gate high switches to scale number 2, while gate low switches back to scale number 1. And then the output is the quantized output. And then on the encoder, you can see you can actually move between the scales and punch in the exact notes. So but you can see here I've kind of put in a bit of a C minor. It's just the note C, G, and then G sharp. So it's not a full C minor, it's just 3 notes in the scale. So the interesting thing here is we can jump to, for example, scale number 2, and we can set this to something like like 3 different notes that are still in that scale to get a kind of like moving pattern between these 2 parts. So let's just say, for example, turn off a bunch of these notes by clicking in the encoder. And so I've got D, D sharp, and G on scale 2, and C, G, and G sharp on scale 1. And then I've got a switch here that can switch between those 2 scales. And then I've creating a kind of like Arpeggiator type pattern using the saw output of the mind phaser through the ripples again. This is really nice if you're using something like an analog sequencer, because now we've kind of written this, how can I say, it's almost like a melodic or chord structure, and we can change the sequence while still retaining that kind of like relationship between what notes are allowed to play in what parts. So essentially we're just creating a different kind of rhythmic tone to the arpeggiator. Check it out. So now I'm going to just turn some of the knobs on my analog sequencer, which is off screen, and you're going to hear the difference, and then I'm going to carry on just switching between the 2 scales like I was doing in the previous example. next mode is called the Schmidt trigger. So what this is you can kind of think of it like a compressor. It takes a CV input, and when the CV voltage goes above a certain threshold which you set, it triggers the output. So this is really nice for deriving a gate signal or a trigger signal from something like an LFO or something like that to create these kind of bouncy ball type patterns. Let me just patch it up for you quickly. So I'm going to run just a sine LFO into the CV input over here. And what I'm going to do is I'm going to control the speed of that sine. And you can see we've got the control to set the amount of threshold here using this control. And as you can see, as we set it down, it starts to trigger this output here. You see that little flash. Now what we can do is we can send this output into something like a envelope and then run a signal through it to create something like a bouncy ball pattern. Then we modulate the speed of the LFO and we get some cool glitchy patterns. So it's a simple module. It doesn't require any trigger inputs or anything like that. The CV inputs just control the level input, and then obviously the outputs are the actual triggers, and it's a 2-channel. The next mode is scope, which is a super handy sort of CV oscilloscope, which is great to just quickly like call to, you know, outline something. So I can show you guys, for example, what the CV of this LFO looks like by patching it into that input. Check this out. I'm going to use a different random to control that LFO speed. So now you can see a nice little readout here on the screen of exactly what that LFO is actually doing, and how it's being randomized and that kind of thing. Now the output we can patch back into the input of that Schmidt trigger to create the patch again. So we can both see what's happening with the modulation as well as recreate the patch. Here's something really cool. If you patch a clock into the second trigger input of the scope, that's what it uses to determine the wavelength of the scope. So you can use this if you trigger it on 1/16 to get an exact kind of like curve of what was happening on your 16th. So this is great for phase aligning modulations and anything within the rack, because you can quickly visually see, you know, every 16th note what that modulation is doing. Very, very handy little thing. We can also freeze the scope by clicking. And you can see you get an exact replica of what was happening at that moment in time. Very handy little thing for having in the rack. The next mode is Sequence 5, which is a very simple 5-step sequencer, of course. How it works is this, the encoder basically controls the volume of each step or the voltage of each step, and then a control press in will change the next step. If you turn the voltage all the way to 0 or below 0, it disables the step. So now you've got a 4-step sequencer, a 3-step sequencer, etc. So it's a little bit flexible, but it's really cool for creating these like really versatile polymetric patterns, especially alongside the scale duet. As I just showed you guys a little bit earlier, how you can switch between these two different scales to create this moving, almost like techno melody using the scale duet. So I'm going to use these modes in combination, quickly patch it up, and we can see what we can come up with here. So CV going into the first input actually controls the transpose of the sequence. So this is called to transpose up and down to the key of the track that you're working in. And the outputs are obviously the voltage and then a gate trigger which is derived at the first step when it resets every time. The next mode is shift gate register. The easiest way to describe this is it's kind of like a Turing machine or sample and hold random generator. It spits out either gate or trigger signals. You can choose, using the encoder, you can choose whether it's triggers or gates. In this example, I've got it with triggers. And then the inputs correspond to modulation inputs. And those modulation inputs would change the gate patterns that are being created by the shift register. So this is the result. So this module requires a single clock input, and the second input would freeze the register. It will freeze that input so it loops that signal over and over again. So if you get a rhythm that you like, you can plug this in and it then loops that rhythm over and over again. So the next mode I want to look at is shift register. This is basically a Turing machine, Turing, randomizer, kind of designed for randomizing melodies and pitches and that kind of thing. So the two CV inputs correspond to the length of the sequence that it kind of generates, and the second one corresponds to the probability that it's going to create new values in the sequence. The shift register actually has a quantizer built in where you can choose from specific scales. That being said, like I said before, the scale duet is the most powerful hands-on quantizer in the Hemispheres mode. I find, just because for me, I don't know what scales are what. I just want to punch in a couple of notes and, do these Arpeggiator style sequences. I find for the types of leads and stuff that I do, I generally end up just picking like 2 notes or 3 notes, modulating between those, and then switching to like a different chord of notes and modulating between those. And the scale duet is definitely the way to do that. So notice how as I plug this in, you'll hear that kind of chord change, and it's a cool way of creating these kind of like modulations between different arpeggiator notes. Check this out. So the next mode I want to discuss is called shuffle. So this is obviously to create shuffle or swing. What it does is it takes a gate input and then it offsets 2 out of every 4 of those clock signals. And you have a percentage offset for each one, which is controllable over here. Super interesting, because not many modules allow for this except for like dedicated clock stuff. So having something that you can quickly just use, because I mean, for myself, I don't use shuffle a lot, but yeah, having it as a little mode in the Ornaments and Crime is just an extra bonus if I do ever need it. So here I've rigged up a simple drum beat, and we're going to play a little bit with the shuffle. You can actually control the shuffle with CVs as well. That's a little bit weird. I would never really use that, because what's going to happen there is you're going to get this kind of varying shuffles which aren't going to be too rhythmic. But that being said, you might want to like preset control that or something like that. So having the CV inputs is just, it's nice. So the next mode I want to discuss is Skewed LFO. So this is a very simple triangular / saw LFO. You can set the speed and you can also set the skew. So you can set it to more of a ramp shape, more of a triangle shape. And that's what the encoder does over here. You've also got CV inputs, which modulate the rate and the skew of the LFO. The outputs are obviously the modulation output and then the end of cycle output. So what this does is it sends a trigger when the LFO reaches the end of the cycle. So what you can do is use this to reset the other LFO or do all sorts of things within the patch, like trigger a drum sound or anything like that. So here what I want to do is I actually want to modulate the rate of one of these LFOs with another LFO. The first LFO is controlling the pulse width modulation of a square wave, and the second LFO on the second mode is controlling the filter cutoff. So what we can do here is we can use this end of cycle trigger of the second one to trigger the beginning to reset the first LFO. So what that's going to do is it's going to give us the same phase, the same pulse width modulation every time that kind of pluck hits. Give us slightly more of a stable plucky sound as the kind of bouncy ball pattern progresses. Another interesting thing we could do is we could set this to trigger the end of the cycle, to trigger the clock on a sequencer, and then let's just set this to something like scale duet again. We can quantize the output from the sequencer, send that into the pitch of the oscillator instead, and that's going to create a sequence which has this bouncy ball pattern. We're going to want to clock the input of the quantizer so that quantizes at exactly the same time as that note is plucked. The next mode I want to discuss is called slew. So I've got the same analog sequencer running through scale duet and then through slew. So slew is the way of creating glides or portamentos in the modular environment. How it works is you kind of set the glide up and glide down time using the parameters over here, and then the trigger inputs defeat what's happening there. So you've actually got two channels. One being linear and one being exponential. So for the pitch, I've set it through the exponential, which is the second channel, and the gate basically defeats the glide. So I'm going to send a gate signal in here, and as you can see, as you trigger it, that turns off. So this is how we'll be able to trigger glides on and off. The next mode is called Squanch, Shifting Quantizer. This is a shifting quantizer that can be used as a precision adder. So I've got a sequence, analog voltages coming into CV input number 1. CV input number 2 is taking the attenuator offset voltage from the second mode. So essentially what I'm doing is I'm adding or subtracting that voltage from this, and then it's got a little built-in quantizer, which is really cool as well. Yeah, this is nice for taking the sequence that you have and then tuning it or transposing it into a particular key. You don't necessarily have to send it a voltage. You can also just attenuate it using the parameter with the encoder. The next mode is switch. This is a very simple sequential switch. I'm sending it two modulation sources. One is random and one is a clocked sequence. And what we can do then is use a trigger to switch between which of these two inputs is sending to the output. So there's two channels in the switch, and how it works is it takes the two inputs and the two triggers inputs derive which of those sends to the two outputs. So there's two modes of sequencing. You can either use sequence mode, and each channel represents a different mode of sequencing. So channel 1 is sequenced, so each time a trigger arrives at the input, it goes to the next sort of block in the sequence. And this one is, as long as the gate is held, does it move to the other switch. Does that make sense? So with this one, let's actually put in a longer gate time, and then I'll use an actual physical switch to kind of hold that down. We can switch between them that way. The next mode is TL neuron, or threshold logic neuron. So this is weird. It's like a small part of the neural net system, which is one of the advanced things in Ornaments and Crime and Hemispheres. This is just a single kind of molecule of the neural net system, and it's very complex. I'm not going to try understand. I don't even understand it. I'm not going to try explain it to you guys. But how it works is you feed it 3 triggers. So the CV input becomes a third trigger input. Each of these can be controlled like different numbers and stuff, and the output derives different rhythms and stuff, and they kind of just always sound cool rhythmically. I don't know how it works, I don't know what it does, but super simple rhythmic generator by just feeding it. It's cool for if you've got like a bunch of other things happening in the patch, you can kind of melt those, feed it to this, and derive an extra rhythmic thing to kind of layer in over the top that's a combination of all the other rhythms that's happening. The next mode is called trending. How this works is you've got assignable outputs for rising and falling. You send it a CV input. In this example, I've got an LFO running from the Skewed LFO. Notice how what's happening here is every time it rises and falls, you get a representation of it on the spectrum over here, this little readout. We can change the speed and you'll see it flipping quicker. Here, if we skew this LFO all the way to a saw wave, you'll see that it's constantly in the falling position. Other way around, it's constantly in the rising position. What does the training module actually do though? So here, it derives a gate, whether the input is in the particular state which you've assigned. So in this example, let's set C to rising and D to falling. You've also got moving and steady, change state, change value, and various other things. So falling is every time it falls, it derives a gate. Moving is if it's moving, it's deriving a gate. Steady is if it's not moving, it derives a gate. Change state is no matter what state it's in, if it changes, it derives a gate. So if you're sending it a random trigger, stuff like that, it'll change the state. Change value is very smaller increments of a change state. So let's set this to falling, and what'll happen now, let's say for example, trigger one drum sound on a rising and one drum sound on a falling. And then you can see as we kind of increase the speed of the LFO, we'll get like a drum roll kind of thing happening. Let's try this out. So I've realized that the CVs correspond to the 2 CV inputs. So I've realized the 2 CV outputs correspond to the 2 CV inputs. So I've melted the LFO, and I've actually switched to a different LFO, which I know can go a little bit faster. This might be cool for triggering kind of more riser type drum roll effects. And we can use the Skewed LFO and set this into like a saw up ramp to modulate that other LFO. The next mode is TrigSeq, or Trigger Sequencer. This is a dual 8-step trigger sequencer. And my favorite way to use this is to load it up on both hemispheres. Then you have a 4-channel trigger sequencer. You can change the hits using the encoders. So how it works is you've got various different, it like splits the triggers into multiples of 4. And you can kind of cycle through various different styles of hits, as you can see here. So I've got different drum sounds being triggered by these different lanes. If you click once, it goes to the next little multiple of 4. And click again, and you can actually change the length of the sequence. So you can create like polymetric type of things here. So this is what we're dealing with. The next mode is Trig Seq 16 or Trigger Sequencer 16. It's essentially the same thing. Instead of 2 lanes per hemisphere, you've got 1 lane per hemisphere, and each lane has 16 steps. It works in the same way where you can choose, and then the last one also can change the amount of steps in the sequence. Here, the outputs are actually swapped between ons and offs. So you can see you've got white triggers and black triggers, and the outputs are triggering on notes and off notes. Does that make sense? I forgot to mention as well, with both trigger sequences, when CV is present at the CV inputs, it basically swaps the outputs. So that's a nice way of quickly swapping around inputs and outputs to create varying sounds, varying rhythmic patterns to kind of create fills at the end of bars and stuff like that. The next mode is a tuner. So you send it a signal input and it detects the pitch of that signal, of course. As you can see here, if you try load it up in the left hemisphere, it will tell you tuner goes in right hemisphere. For some reason, I'm not sure why, but tuner can only load in the right hemisphere. So generally speaking, if I'm doing like patches that are going to stay patched, I will leave my right hemisphere open just because of certain modes that will only go in the right hemisphere, like the tuner. But that being said, just so that you know, very simple tuner. So the next 4 modes, Vector EG, Vector LFO, Vector Mod, and Vector Morph, all derive their waveforms from the bank which you can draw in of waveform editors. Remember I told you can access the settings menu by long pressing on the right encoder, and you can just cycle down to waveform editor, and you can actually load up. You see I've drawn this particular one, it's like Batman's head. I've drawn that in the waveform editor, so then you can just jump back into your hemispheres and you can load up waveforms that you create in that waveform editor within the vector modes. You can also do it, you can also edit your BootsNCat waveforms in the waveform editor. But I'm going to save that more advanced stuff for a separate video if you guys are keen for that kind of thing. Anyway, how these differ is the Vector EG is obviously an envelope generator. Vector LFO is obviously an LFO. Let's look at these ones first. How it works is it's 2 channels. You select which channel is doing what by using the encoder. You can actually select a unique shape for each channel. So this is pretty crazy. You could do, for example, like a exponential curve and a linear curve. Let's not do a half saw. Let's do the full saw. I'm sure I've got one somewhere here. There we go. So A and B. So now what we can do is we can create, we can like gate this with a single input or 2 different inputs and control a single sound, but have, for example, like a more linear curve on the filter and a more exponential curve on the VCA, or vice versa. You can set the speed of each of the vectors independently. Vector LFO is same but different. Same interface and stuff. You can also choose the shapes and the speed for 2 separate channels. This is a pretty wild way of creating custom LFO modulator shapes by sending it into like something like a filter, turning the resonance up a little bit, and then you can set this hertz up to 999 hertz, and that creates that audio range modulation that gives it that grindy texture. And then you simply just choose a waveform and you get all these different crazy things happening to the sound. In the Vector LFO mode, the CV inputs correspond to the frequency and amplitude of the vectors. I'm still not quite sure about how vector mod works. It's apparently supposed to be both an LFO and an envelope generator, but I'm not quite sure how to change between those different modes. I guess maybe it's got something to do with the CV inputs and stuff like that, but it's a little bit complicated. I guess you could just use either of the other ones. I guess the best way to explain vector morph is it's kind of like a function generator where you have a waveform which you can draw in the waveform editor, and then you can offset the phase of where it's grabbing that value. So you can either kind of play it using the encoder, or you can send it modulation sources. So for example, if we send it like a ramp, you'll see that it'll kind of go through this shape sequentially. Let's give it a ramp down. So the last mode is the voltage mode. This is very simple, kind of like the attenuator, but it's not quite. It's more like just the offset. But this has various kind of gate modes where you can choose whether it's gating on or gating off, and you can also modulate the voltage amount with an external source. And then the outputs are just the kind of raw voltage that you set on each channel like that. Simple as that.